Welcome in, everybody, to episode 14 of my Pro Unreal Engine tutorial series here on YouTube. Today, we're going to be hooking up the walk animations that we worked so hard on last time. And to do that, we're going to do some work in the anim instance, C++ files, as well as the character, and we're going to make something called an animation blueprint, which is going to drive all our animations throughout this game. So yeah, pretty exciting stuff. And as you can see here, I have one task made called Hook Up Walk Animation Blend Spaces. So feel free to pause the video right now and make that task in your backlog. And as always, we'll go over the description in a second here. But yeah, the main thing that we're going to have to do is make some changes in the anim instance that we made. And then from there, we'll make our anim BP. And we'll call this done once we've tested in-game and we can see everything working. And also today, I'm going to use this opportunity because we're going to need it to test to do a quick overview on networking for you guys. So that'll be exciting as well. Because most courses won't even get into networking for beginner stuff. But I think it'll be easier to do it early and often so you guys can learn the fundamentals as we go. And we're not just going to reach a point where we add multiplayer into everything. Alright, so then we want to make this an art and an engineering task and put it under that player character epic, per usual. And so now we're going to head over to our Jira board and we'll get things going. We also want to drag that into the board, obviously. And we'll put this into in progress. And I don't know why I keep forgetting to do this, but if you just want to copy the name like that, then you can use it to make your perforce task and you don't have to remember what the task is called. And if you have a very short memory span like myself, then that definitely is very helpful. Alright, so we have our task list made. And now we can open up our UE5 solution and get going on those C++ changes. And per usual, I'm going to be pasting in the code, but don't worry, I'll be going line by line over what everything means. As thrilling as watching me type in every single word would be, this is just the faster way of doing it, I found. So first, we're going to go into the character movement comp and fix a mistake I made last time. We want that orient rotation to movement to be false. I don't know why I thought it was supposed to be true, but it led to problems when I was testing in my other project. So we definitely want that to be false. Make sure you make that change or else you're going to run into a lot of issues when we go to test. And all the other constants can stay exactly as we have them. Alright, so now we're going to open up a few classes that we're going to need. So we'll need the character. And here we just have to make a getter, which is typically the terminology used for if we just want to give access to something. And see, I just pasted that in right here. But you're definitely going to notice a few new things in this function, which I'll go over now. So first we have that force inline specifier, And what that means is it's forcing us to have the entire function in this one line. So for stuff like this, where we're literally just returning a variable, there's no need to put the function definition in the C++ file. We can just do it here. It's just easier and takes up more space. And we also have that const flag, which is basically just a promise that we aren't going to change anything within this function. So if, for example, we tried to modify one of the variables in this function, it would pop up with an error and say, this is a const function, you can't modify anything. So it's basically just a promise that we aren't going to make any changes, and the caller will see that when they call the function. And yeah, that's pretty much it. So just the force in line and then that const keyword is the stuff that I haven't explained up until this point. So now we have that all set, and we can move into the anim instance. So we'll open that up, the .cpp and the .h. And this will also be the CCS version because we want this to carry forward with every anim instance we make. Because we're going to be adding in some key functions here. And again, pasting everything in, but don't be nervous. We're going to go line by line. And the first thing that we are going to update here, as I make a little bit more room, is the public section. And we're going to make our usual default Unreal Functions public region. And we just put a constructor in there for completeness sake. We're not doing anything in there. And then the other one is the initialize animation function. And this is basically the begin play for the anim instance. I just put it in here if we want to do something in there in the future, but we aren't doing anything there yet now, so good to declare it, and it's an override of a base anim instance function, and that's why we have that override specifier at the end. Because some people like to verify things in there, but I prefer to do it in the native update animation, which is essentially the tick function for the anim instance. And this is the function where we're actually going to be doing our calculations and driving the variables that we need to run our blend spaces and all the other animations that we use. So for here, we're going to have direction and speed. And those, if you remember, were the two variables we put into our blend space. And to make those calculations work, we're going to need a reference to the character and the character movement component. So that's why we have these get and check references functions. And you'll remember these from the past few times. I have these scattered all around my projects. So nothing new there. And then we have our anim drivers. And you see we make these blueprint read-only. And that's because we need to access them in the animation blueprint that we're going to make. But you'll see that later. For now, just take my word for it, but we have speed and direction. And as we continue to develop this project, we're going to add more animation drivers, and we're going to update all of them, each frame in the anim instance, in that update animation function. So that's kind of how that works. And then nothing new here, we just have references to the character CCS and character movement component CCS. So just put that in your references category there. And we have to use that uProperty flag to make sure they don't get blown away by the garbage collector. And at the end of here, we have our parameters region. And we have a rotator for our update animation rotation. And just take my word for it, we're going to need that. And I'll explain why later. And then we have our interpolation speed, because we're going to have to be manually interpolating the character rotation because of the direction calculation. And I forgot to forward declare the variables there, so we're going to get an error when we go to build. And in the CPP file, again, I'm just going to paste everything in. So first we have our anim instance CCS constructor, and that's all good. We also have these header files we've included, and see we're not finding a few of them. And that's because we have to add the module into our build.cs file for the plugin, just like we did last time, because we need that Kismet animation library. And I'll just copy what I did in the creators file. So we need that anim graph runtime is what we need to put in. And we don't need to add it to the plugin to get that error for some reason. I'm not sure what causes that error to come up and what it causes it to not come up sometimes. But this is one of those instances we just need to throw it in the private dependency module names and not in the actual U plugin file. And now that we have that all set, our little squiggly will go away the next time we reopen. But it'll stay there for now, no big deal. So yeah, we have our first two functions where we're not really doing anything. All we're doing is calling the parent version of our native initialize animation. So nothing too revolutionary there. And in the update function, we first call our parent's version. Then we get and check our needed references per usual. And then next, we are going to calculate our speed. And that, you'll remember, is just the size of the velocity vector for the character movement component. If you remember from your high school physics class that you took, I'm sure they'd be very proud of you now for remembering it and using it. And then the next step is going to be to start calculating our direction. And the first thing we need to do is call this function on the character to get our aim rotation. And that is pretty much exactly what it sounds like. It's just basically where the character is aiming and a rotation value for that. That tends to be the best way to calculate direction. There's a lot of different rotation values you could use, but that is kind of the consensus one to use for this. And then next, we want to calculate our movement rotation. And we're using a helpful function to make a rotator from a vector. And that's what we're doing there. We're making a rotator from our velocity value. And then next, we need to calculate the difference between our aim rotation and our movement rotation, which is what that function there does, in addition to normalizing the vector, which means that it gives it a magnitude of 1 and then adjusts the x, y, and z accordingly. And by the way, if I ever talk about size when it comes to vector, that means the magnitude. That's just the terminology that Unreal uses. So that's the terminology that I'm going to use, unless I do call it magnitude. But just know when I'm kind of transitioning between those two terms, I mean the exact same thing. So then we have our movement to aim rotation, and we're ready to do our interpolation. And the reason we need to do the interpolation like this is because if we're just using a standard interpolation, we run into an issue with our blend space when we're walking backwards. And this is because the value will jump from negative 180 to 180 over and over again. And if you just straight up try to interpolate that, it will go all the way from negative 180 to 180. And our animation blend space is going to freak out when that happens. And this R interp to function makes sure that we're taking the shortest possible path. So it understands that negative 180 and positive 180 are essentially the same thing, and it won't try to interpolate across the entire direction range. And we also are using this to apply the interpolation speed. And at the end there, we just kind of take the yaw value for direction and we're all set. And then here we just have our get and check functions that you've seen in all the other places across the project. So nothing new here. We just get the various components like the character movement component in a slightly different way. So you see that's where we're using that getter that we made on the character.h file. So good to see that in action. So now that we're done with that, we can try to build. And remember, we're going to get an error because I forgot to forward declare those class types on the animinstance.h. Oh, and I forgot to do one thing here. We have to go to the camera comp and we need to set some field of view and aspect ratio stuff in here. And you'll see I'm just going to paste this stuff in. And what this is doing is locking the aspect ratio at 16 by 9 and setting the field of view of 80. And this will become important as we start testing with two players playing at the same time. Because things won't look like they do in our Blender file if the aspect ratio isn't 16 by 9. And I'm sorry to everyone who has a wide monitor, but this is kind of one of those things. It makes it so much easier just automatically locking it to 16 by 9. And then we won't have to worry about that ever again. If people really want that feature, we can add support for it. But just take my word for it that it makes things so much more complicated, especially when we get to UI. That's the big one where it's going to cause big issues, as well as with our first person animations. So now we have everything done and we can actually build. And remember, we're going to get a couple of errors here because I forgot to forward declare our character movement component and our character in the anim instance. Yeah, so see all those undeclared identifiers? They really do make the errors look so terrifying. It's very funny to me. So yeah, I figured out what was wrong pretty quickly. And that's the biggest thing when you get an error. You just have to not panic and then go fix it. And I forgot here that it's U character movement, not A character movement. And the reason for that notation is if it's an actor, then it's A. And if it's not an actor, then it's B. That's kind of the reason behind that. notation within the Unreal source code. Alright, so it built, no errors, no warnings, we're looking good. So now we can open up our game here. And we can actually get into this, which will be nice. So the first thing we're going to do is make our animation blueprint and make sure you're following along very closely because there's lots of opportunities to screw up here. So we're going to go to the top level of our animations human folder and we're going to make our animation blueprint. So right click animation, animation blueprint. And here we need to make sure we pick the right skeleton. So now there are two UE4 skeletons, and remember we want the one under characters. And then for parent class, we want to pick the anim instance that we just updated. So anim instance HSS, in case we want to make any small adjustments. Only for hide, seek, survive, not for the larger CCS core. And this is the notation for the naming. We want anim BP. And we forgot an underscore there. So it's human underscore third person HSS. And you'll see me fix it in a second here. Yep, there we go. And we forgot to do the descriptions. And we'll just have to modify the anim instance.h. I don't remember when I do that, but I realized that mistake eventually. Oh, it is right now. Fantastic. So yeah, we just want to update this to say that it now calculates all the drivers that we need. And we can specifically call out speed and direction. And all the other classes we modified, we didn't really do enough in there to merit updating the description. Actually, we did modify the camera enough that we should probably update the description, but I'll remember to do that at the start of the next video. And if I don't, hopefully I'll remember to do it the next time I'm in there. Alright, so looking good. And now that we have that taken care of, we can go into this anim blueprint. And this is what's called the anim graph. And this is the event graph. And you'll notice in most animation blueprint tutorials, they get all those drivers here, but we're going to do it in the C++ because it makes it just more clean and easier to transfer to other animation blueprints. So the first thing in here, we're going to make a state machine, which is just a device that lets us control what state the animation is in. And we're going to call this upper body. And for this, we're just going to have one state and make sure you drag in the upper blend space, not the lower. And we're just going to call this walk. And then we drag the little arrow. And eventually we're going to fill this out further so there'll be more states. And we want to duplicate it and call this one lower body. And we'll click into there and click into walk. And we need to change this to the lower body blend space because we're in the lower section. And see how we have those direction and speed pens? This is where we make use of those variables we made. So see, we have our animation drivers, and we just plug direction in. So right click, get speed, and plug it right in, and compile and save. And we can actually just copy these and head over to our upper body and just do the exact same thing. All right, looking good. So compile again. And it's just good to always be saving and compiling because if your engine crashes, you don't want to lose a whole bunch of work. And speaking of saving, we're going to cache this pose, which basically means we can use it throughout the animation blueprint and just call it upper body cache. Or you can just call it upper body pose. That's fine as well. But basically, we're just saving this off because we're going to need it in multiple places. So it calculates itself and then we can use it. Because as you'll see, the animation blueprint will behave differently depending on whether or not this is the third person or the first person animation blueprint. All right, so we'll make some room and we want to search for layered blend by bone, well, per bone. And what this is going to do is we assign it a base pose and then we put in a blend pose and it will blend the two together at the specific bone that we input. So we can save, and I'll go to the skeleton just to show you guys. So see how we have the spine 1, spine 2, spine 3? So we want to keep that on the lower body professionally made animation. But the arms, we want our own custom animation to play there, obviously. But the rest of our custom animation, it isn't really doing anything, so we want the rest of it to play over. So what we want to do then is go into here, and this has to be typed exactly correct or it won't work. So we want to put the bone name in here as clavicle underscore L because that's going to cover everything in the left arm, and clavicle underscore R will do the same for the right arm. So see how that matches what's in the skeleton? So now we have that blend set up. And next we're going to have to make a variable. And we'll just call it need third person. And by default, this will be on because this is the third person blueprint. But you'll see when we make the first person one, we're going to switch this to off because we don't want the extra calculation happening when we don't need it. It'll just make performance better if we disable it using this blend. So now we're going to search blend poses by bool, and we plug that need third person right in. And we want to set the blend times to 0. I'm pretty sure I'll do that in a second here, but set those to 0. And as I said, we plug in the lower body as the base pose. And then we take our upper body cache and plug it into the blend pose. Oh, and by the way, the comment I'm making there, you highlight everything and press C on your keyboard, and it'll make a comment. That's how I'm doing that. And then we want to plug in the same cache pose to false and see updating the blend time there. But yeah, we just want the upper body if this is the first person, and see how we compile. And it looks a little funky, but we'll fix that later. Not terrible, but we should probably fix this. And we'll take care of that at the beginning of the next one. And what we want to do in here in the map is we want to go to the player start, and we're going to duplicate it. And then you just drag it using the little arrow there. And to get that, you press E, and then you can rotate it to face the other one. And that's going to be critical for our testing, so make sure you do that. And now we get to the point where we're going to use networking, and I will go into a brief explanation of what that is and how that works in Unreal. And we find ourselves here in the Unreal networking overview documentation. And just ignore the text. We'll use the images though. So the top one demonstrates how we've been playing the game as of now. So we have the one machine that's running the game, and we are one of the controllers plugged into the game. So in theory, we could set up split screen, etc. And we haven't done that yet, but we could. So this is called the standalone configuration. And then next, we have the number one below. Unreal runs their networking, which is just the other word for multiplayer games. Like if you go play Call of Duty, etc. So they run their networked games on a client server model. So how that works is there's a server somewhere. So this is exactly how it works when you go play Call of Duty. So there's a server somewhere out in a data center, and that contains the truth of what's happening in a game. And then each player is a client. So that just means they're one of the players in the game connected to the server. So what happens is when the client does something, they send data to the server saying, hey, we just did something. And then the server reacts to that and sends that data back out to the other clients. And that's kind of a high level description of how networking works. And where it starts to be difficult as a programmer is you don't want to send a lot of data over the network. So the whole balance is making the clients all see the same thing as the server and making everything appear to line up correctly while sending the least possible amount of data. Because if you send too much data, you'll get packet loss, lag, and all sorts of bad stuff. So that's kind of the dance we're doing as networking engineers, which, news alert, you are one now, because we're going to start doing that right now. But yeah, and then the other thing is you'll see when we go back to Unreal, there's play as client or play as a listen server. And if you're playing as the listen server, that means that you are not working in a dedicated server format. So when I went back to the Call of Duty example, today there's a server in a data center acting as that server for the game. But back in the day, when server space was really expensive, they would just make whoever in the lobby had the best connection the host. Well, I'll say the best connection to all the other players. But, anyways, if you ever played Call of Duty like 15 years ago and got the mid game pop up, the host has left the game, establishing a new host. That is why. Because at that time, they weren't actually running on a dedicated server. So if we're pressing play as client, Unreal is simulating a dedicated server and then two clients. And if we press play as a listen server, then it is simulating one player acting as both a client and the server. So, in other words, the host, and the other player is just a client hooked up to that game session. So, I know that was a lot of information right there, but that's just at a high level how networking works. And we'll get back into the rest of the content here. And don't worry, this will start to make more sense to you as we go along and start programming in networking functionality. And this is part of the reason why we use the character movement component, because it already has all that stuff built in. So here we want to press number of players 2, and then we'll pick play as client, because that's kind of the hardest configuration. So that's what I like to test. All right, so we press play. And now we can move around everything. And there we go. See, we have the two windows. And our guy isn't animating at all. And the reason is because I forgot to plug in the animation blueprints in the character. I also forgot to make the first person one, but we'll do that in a second. Alright, so we go to our mesh, and we switch from use animation asset to use animation blueprint. Yeah, and see, I realize I forgot to make the first person one. So go right where the third person one was, and right click, create child. I duplicated, but you don't want to do that. But you want to create child. There we go. And we want this to be called the same thing, but switch third person to first person. You see, that's what I'm doing now. Got a weird pop-up about source control, but it seems fine. So we'll march ahead. And we can delete this event graph stuff again, just so we don't get confused later. And we want to go into our class defaults and update need third person to false. And that's the only change we should need to make. And the reason we're doing this is so now, as we select the third person for our third person mesh, we need to make sure that when we update one of these animation blueprints, as I add an underscore for consistency, we are updating both of them. Because it would be very tedious to have to update both of them every time we make a change. So that's why we set it up like this. Alright, so we're looking good. And now we can see our guy is animating. And see, we can see on both sides. So on the left, we have the first person is firing pretty well. On the right, we have the third person, and it's not quite facing forward, so that's going to be what we fix at the start of next time, because we're going to have to make that look right. It won't really matter so much for this game, but the second game in this series is going to be a multiplayer first person shooter. So it's definitely going to matter in that one. It'll look really weird if the player holding the gun, looking at you, is facing away. Alright, so we can call that tested. And now, as always, we can start packaging up the project. So we'll go in and delete our old build and kick off a new one. Alright, so package it up. And I'll fast forward until mine is done. And now we can close everything down. And just be aware that the networking simulator doesn't work in a packaged project, obviously. So it'll just be in standalone. So we're just going to be able to see the first person and just know that the third person is still working. Alright, as we triumphantly walk around here, we're looking pretty good. Quite a lot of progress we've made in the past few episodes, so that's always good to see. And yeah, you can see I'm really enjoying walking around right now, getting our animations all tested, and we can call this done, I think. So we'll go to our board, throw it into review, and then get all our files checked in Perforce. So this all looks good. I don't think we're missing anything. So we can add it to our numbered change list. And I'm going to go in here and check and make sure everything's in. So we're looking pretty good. And maybe at the start of next time, we're going to do a quick audit of Perforce and make sure everything's checked in. Yeah, that'll be a good thing to do. I'm sure we're missing something. Alright, we can add our little comment, and we can call it a day. So yeah, thank you as always for watching. And in the next one, we're going to do an audit of Perforce to make sure everything's all good. Then we're going to fix up our third-person animations. And then we can actually go into making our crouch animations. And then we'll retarget the crouch walk animations from the anim starter pack, and we'll create our animation blend spaces for crouching. And then when all that's done, that'll probably be it for that episode. We're going to make our character be able to crouch and then crouch walk. So that'll be very exciting. And as always, definitely like the video and leave a comment if you're enjoying this series. And let me know if you have any feedback about what I could be doing differently, because that's the only way these will get better. And I'm really hoping that these videos are giving you guys a lot of value. So definitely let me know. And if you want to keep up with the series, then subscribe to the channel, as I'm going to be posting a new video every Tuesday, Thursday, and Sunday moving forward. There's a possibility I'll go to 4 videos a week once the summer's over, but we will see. And with all that being said, thank you so much again for watching, and I'll see you in the next one. Later.